Okay, here we're going to talk about a bunch of relationships between all of our different trig functions that you definitely want to write down in your notes, and you're really going to have to memorize. And by the end of the semester, you'll definitely know all of these, I hope. So we're going to start with what we call the reciprocal identities. And reciprocal really means just taking a fraction and flipping it over. So here I've drawn this triangle ABC, and I've written down some of our trig functions all here. I've written all 6 at angle A. Like, for example, sine of angle A is the length of the opposite side divided by the hypotenuse, and opposite angle A is side A. And let's look, for example, maybe at cosecant of A. Recall that cosecant is hypotenuse over opposite. So from angle A, hypotenuse over opposite, wait a minute, that's the same letters, just flipped over. Well, they should be. Sine is opposite over hypotenuse. Cosecant is hypotenuse over opposite. These two are buddies. They're just flipped over. Same thing with secant and cosecant. And same with tangent and cotangent. I mean, look, it's just a fraction flipped over. So in general, sine of any angle is just 1 over cosecant of that same angle. Cosine is 1 over secant. And tangent is 1 over cotangent. Or, identically, I could say cosecant of any angle is just find the sine of the angle and flip it over. Secant is just take the cosine and flip it over. And cotangent, you just find the tangent, write it as a fraction, and flip it over. Now, the way I have these memorized, I've been doing this for over 20 years. I do not have memorized that secant is hypotenuse over adjacent. Like, I literally just figured that out as I was saying it. What I have memorized is secant is 1 over cosine. Sine, cosine, and tangent, so SOHCAHTOA. Those you memorize. And then you memorize these right here to get the other 3. And the way I have this memorized is it would be very convenient if the cos went together. I wish that cosine matched up with cosecant. That would be easy to remember, right? Cosine goes with cosecant, but it doesn't. Cosine goes with secant. The cos do not match up. Okay, so these are our reciprocal identities. And then there's another identity I like to put here because it also involves fractions. And that's that tangent of any angle is always the sine of that angle divided by the cosine of that angle. When I say tangent, right now you're probably thinking opposite over adjacent. But as you get further along in math, it's much better to think of tangent as sine over cosine. So let me at least try to motivate that here. So let's say we had sine of A over cosine of A. Just based on what we've written here. That would be A over C, that's sine of A, divided by, big fraction bar, cosine of A. So I've got a fraction divided by a fraction. I have to do a little keep, change, flip. So keep the top one. Change divided to multiplied, flip over the bottom one. So this would be C over B. Hey, those C's cancel, and I get A over B, but wait a minute, that's just tangent of A. And that will always work. Now, there are some domain issues we'll have to talk about later. Sometimes the cosine equals 0, so tangent is undefined. But yeah, we'll deal with those issues later. In general, tangent of some angle is always the sine of that angle divided by the cosine of that angle. Okay, next, let's talk about what we call the Pythagorean identities. So I've got some right triangle here. I've got it labeled the standard way we label this. And I'm going to claim for any angle, sine squared of theta plus cosine squared of theta will always equal 1. Okay, so a note here first, because sometimes this causes confusions. Mathematicians are weird. When I say sine squared, that doesn't mean square the angle. That means find your sine of that angle, which is going to be a fraction. Remember, trig functions, you give them an angle and they spit out a fraction. Then take that fraction and square it. And I claim that you start with any angle theta, and this actually does work for any angle. Find the sine, square it, find the cosine, square it, add those fractions together, you'll always get 1. So, like, this won't be a full proof, but let's look in this right triangle and let's do sine squared of A plus cosine squared of A. So I can at least convince you this is true. So sine of A will be opposite over hypotenuse. And then we're supposed to square that fraction. Cosine of A. So I'm at angle A, adjacent over hypotenuse, so katoa. Square that. Okay, how do we square a fraction? We square the top and we square the bottom. So that'll be a squared over c squared plus b squared over c squared. Now I've got to add these fractions together. I have a common denominator. I can just add the numerators. Wait a minute, we're in a right triangle. Like, the whole point of the picture I've drawn here, this is a right triangle. I know what a squared plus b squared is. That's c squared. That's Pythagorean theorem. There's a reason these are called the Pythagorean identities, because they literally are just Pythagorean theorem. A squared plus b squared is just c squared. But c squared over c squared is just 1. Okay, so in general, sine squared of theta plus cosine squared of theta will always equal 1. This one you want to have memorized. We're going to use it all the time. This is very important. These next two, I'll show you later how to derive these. So you really don't even have to memorize these next two, because I'll show you how to derive them, and I'm not going to prove them right now. The next one is tangent squared plus 1 is always equal to secant squared. And the last one is 1 plus cotangent squared of any angle is the cosecant squared of that angle. So write those down in your notes. The top one we're going to use all the time. Very important. Okay, next we're going to look at what we call the cofunction identities. So again, I've drawn a right triangle here, and I've just written down a couple of our 6 trig functions at a couple of different angles. Like, there are 12 different things I could write down here, but I picked these two. Let's look at sine of angle A. That's opposite over hypotenuse from angle A. And what about cosine of B? So now I'm at angle B, and I want adjacent over hypotenuse. Hey, look at that. I got the same thing. Sine of one angle is the cosine of the other, angle. And when I say the other angle, remember, in a right triangle, we're always going to have our right angle, C, and then we're going to have our 2 acute angles. And those two will be complementary. A plus C will always add up to 90 degrees because there's 180 in a triangle. So the sine of one of the angles will always be the cosine of the other, because opposite from A will always be adjacent to B. So that's always going to be true. Sine of any angle theta will be cosine of 90 degrees minus theta. Or if we write that in radians, how we typically write these, we might say sine of theta is the cosine of pi over 2 radians. Remember, 90 degrees is just pi over 2 radians. And that's true for all of our co-functions. This guy is called cosine for a reason. He's sine's buddy. They're co-functions. Sine of one angle is the cosine of the complement of that angle. Same with secant is the cosecant of the other angle. And tangent of any angle is the cotangent of the other angle. And these all work the other way as well, of course. Cosine is the same as the sine of the complement. And cosecant is the same as the secant of the other angle, the other acute angle in the triangle, and of course cotangent. You want to write all of these in your notes. Okay, so let's look at just a real quick example here. We could get out our fancy calculator and even check these. Okay, so what I'm saying with all of this is sine of, say, let's just make up an angle, 30 degrees. I can get my calculator out and calculate that. Now I want to make sure I'm in degree mode because it says degrees. So I would go into mode and make sure I'm in degree mode and then quit. And then I can do sine of 30, close my parentheses, and hit enter. I get 0.5, 1/2. We'll see why in a later video. What I'm claiming up here is cosine of the other angle in the triangle, cosine of 90 degrees minus 30 degrees, which it doesn't mean that's not cosine of 90 minus cosine of 30. I'm not saying I can distribute that. In fact, you can't. I mean, just do what's inside. 90 minus 30. Cosine of 60 degrees. Let's get out our fancy calculator and check it. Cosine of 60. I got the same answer. 0.5. Sine of 30 is the same as cosine of 60. And that's true for any angle. And in fact, once we expand our trig functions outside of a right triangle, we'll do that in a later video, these relationships are always true for any angle. So let's pick maybe 17.5 degrees. And let's do tangent and cotangent. What I'm claiming here is that tangent of 17.5 is the same as cotangent, because they're co-functions, of the complement. So I would need to find his complement. I would need to do 90 minus 17.5. $72.5 degrees. Remember, degrees are units. Anytime we're using degrees, you always have to put a degree symbol. And I'm saying that these will be the same answer. Tangent of one angle is exactly the same as the cotangent of the complement of that angle. So real quickly, we could find both of these. Tangent of 17.5 is that number, that nasty decimal. So let's write that down to 4 decimal places, 0.3153. Okay, what about cotangent? We don't have a cotangent button on the calculator. On the calculator, we only have sine, cosine, and tangent. How am I going to find cotangent of this angle? I just did. Or if I wanted to make this more complicated, I could think, oh, well, cotangent of any angle is just 1 over the tangent of the same angle using our reciprocal identity. I don't know if I wrote this one down above. Maybe we should add that here. So go back to your notes here. Cotangent of any angle is 1 over tangent. Or another way to say that is tangent of any angle is 1 over cotangent. Those are reciprocals of each other, as well as cofunctions. Or I could think cotangent of any angle is just the cosine of that angle divided by the sine of that angle. I didn't prove that one either. I proved, or at least demonstrated, that tangent is sine over cosine. But it's also true, using the exact same kind of argument I did here, that cotangent of any angle is cosine over sine of the same angle. So add that to your notes here with these reciprocal identities. So let's do this all 3 ways. So what I'm saying here is, if I want to calculate cotangent of 72.5 degrees, I've got 3 different ways I could do it. I could say, oh, well, that's just tangent of the complement, which is, we just wrote it down, 0.3153. Or I could say cotangent of 72.5 degrees is 1 over tangent of the same angle. So I could do tangent 72.5, get my answer, and then flip it over. Do 1 over that. And there's actually a button for that on our calculator that flips over fractions, or I could just do 1 divided by the last answer. Hey, look at that. I got the same answer. Or I could say cotangent of 72.5 degrees is the cosine of that angle divided by the sine of that angle. So let's do that. Cosine of 72.5 divided by sine. And I need all my parentheses here. And look, I get exactly the same answer. So we don't have secant, cosecant, and cotangent buttons on our calculator. We're going to find other ways to evaluate those. Okay, and that's a good place to stop.